Hey everybody, welcome to lesson 3, building quadratic functions from geometric patterns. This video is going to cover the first problem, the warm-up. As you can see, I've already recorded all of the pieces into my notebook. If you haven't done that already, I would encourage you, when you pause the video, to do all of that. But first, let's read this problem, and then I'll probably tell you to pause the video and try it yourself. So it says, number 1, quadratic expressions in area, warm up. Student task statement. Figure A is a large square. Figure B is a large square with a smaller square removed. So I see that right here, this square. Okay. Figure C is composed of 2 large squares with 1 small square added. You guys catch that square over here as well. Okay. Write an expression to represent the area of each shaded figure when the side length of the large square is as shown in the first column. Okay, so we've got 4 different side lengths here, the number 4, x, 4x, and then x plus 3. So each of these, it could be the side length for the squares in each of these figures. And it looks like they want us to find the area of each of these. So at this point, you should pause the video, try this on your own, and then when you finish, you'll come back and we'll talk it over together. Okay, pause the video and figure out as much of this as you can. Okay, welcome back everybody. So let's remind ourselves quickly, if we need to, what we mean when we say area. So let's give ourselves a little thought bubble over here. This is our area. And when we're dealing with the area of a square, you know, we have like the length down here and the width here, but both of those are the same. So like one side and one side, and so the area are just these 2 numbers multiplied together. But because those numbers are always the same in a square, the area of a square we just say is the side length squared, right? Okay, so what does that look like for our 3 examples? Well, in the first one it says the side length is 4. So then the area of the first square would literally just be 4 times 4, or you could write this as 4 squared. Great. Figure B is really similar to figure A, except there's this 1 square that's been kind of like pulled out of the middle. So we can say that the area for figure B is the same as figure A, 4 squared, except that 1 has been pulled out. And so we have to think, okay, what does that mean mathematically, right? In terms of symbols, if 1 square is being pulled out, that means it's being subtracted. So we're subtracting the area of this little square right here. Remember, the area of this little square is just 1 times 1, which is 1. So we're pulling out 1 square out of the middle. Okay, area C isn't 1 of these squares, it's 2 of these squares. So we can say it's 2 of the 4 squareds, but now that little like extra square isn't being taken away, it's being put in, which means we're adding it. Right. And also, I guess I'm writing 4 squared here, but remember 4 squared, you could also just said 16. 4 squared equals 16. Shift that over a little bit. And so if you had said 16 minus 1 or 16 times 2 plus 1, that's fine as well. Okay, so what if it's x? What if the side length is x, not the number 4? Well, notice it's basically the same setup, right? The side length is still side times side, but now it's just, instead of 4 times 4, we would just write x times x, which is x squared. For figure B, it's still x times x, or x squared. And even though we don't know what x is, we still know that that square in the middle is being pulled out, and that square in the middle still has an area of 1, right? And for area C, we don't know what the side length is, we just call it x, but it's the same thing, right? There's 2 squares, so we can say there's 2 x squares, and we're still adding that 1 in. Okay, this one, we want to be a little careful because this has to do with order of operations, because now we say the side length is 4x and 4x, which means we have to do 4x times 4x. And you have to think about all of the pieces involved here. So if I were to go over off to the side, if I have 4x times 4x, the x times the x would get us an x squared just like before. But there's still the 2 4's here, right? So this is still a 4 times a 4, and 4 times 4 is 16. Right, this has to do with how we talk about multiplying factors together. Because remember, when we write 4x, what we really mean is 4 times x and 4 times x. So we can read this as like 4 times x times 4 times x. And when we do that, the 4's combine, 4 times 4 is 16, and the x's combine, x times x is x squared. So going back, so this is all for area A, right? Okay. So 4x times 4x we can write as 16x squared. Oh, I didn't really give myself enough room. Hopefully you guys can see that. 16x squared. It's over here as well. Area B, well, remember what we've been saying. Area B is basically area A minus 1. So that's easy enough. 16x squared minus 1. And figure C is 2 figure A's plus 1. So figure A is that 16x squared. So then if I have 16x squared times 2, that becomes 32x squared plus 1. You all see where that 32 comes from? If I want to get a calculator, the 32 comes from 16 times 2. 32. Alright, the last one is odd because there's this x plus 3. But the basic idea is still the same. If we say one side is x plus 3 and another side is x plus 3, then the area is just x plus 3 squared, or x plus 3 times itself. Notice I have to use parentheses when I do this, right? Let me highlight that. Parentheses squared. And that's it. That's how we write the area if we know this side is x plus 3. Okay, area B, same thing, right? It's the area A minus 1. So this would be x plus 3 squared minus 1. And figure C is 2 area A's plus 1. So 2 area A's plus 1. Right. And you might want to have to go back and watch this again or think through this again. And if you do that, I want you to focus on kind of one thing specifically, and it's paying attention to where the area A's show up when we calculate the areas for B and for C. So here is area A, and here is area A minus 1. And here is area A times 2 plus 1. And area A and area A minus 1, and area A plus, or 2 times area A plus 1, and then etc., 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 right? Area A minus 1, and then here I wrote it as 32, so you have to remember, like, where is the 16x squared here, and it comes from the times 2, and then plus 1. And here, area A minus 1, and 2 times area A plus 1. Okay, so that's the warm-up for today. Head on to the next video for the next problem in today's lesson.